Hello everybody and welcome to the very last assignment in my class at the University of Advancing Technology. This class is CSC-438 and this deals with artificial intelligence, it deals with algorithms, it deals with machine learning, and it deals with using Unity as a basis for all of the above. So for this assignment, I actually have to try to teach you guys something about machine learning and Unity. So let's get right to it, shall we? I chose the ever popular balancing ball scenario for this because it can teach us a lot. It teaches us about balance, and with balance we have well-being, and with well-being we have a clear mind, and with a clear mind we can accomplish anything. So let's get to it. What we have here are 12 little ninjas, and these ninjas are learning the art of balance, because without balance in their lives they're really not going to go that far. So let's hand it to the ninjas. Okay, now with this scenario, what happens is we're using a bunch of different effects like gravity, and we're using physics, and we're using like vector coordinates. We're using X, Y, and Z coordinates to manipulate these little guys into trying to balance a ball on their head. And in doing so, we have this environment, this 3D environment called 3D ball. And inside of it, we have a bunch of different objects. Each one of these objects pertains to this scene. And this scene has a bunch of stuff in it that is learning stuff. So for example, we have an event system. And in this event system, we have an input system, which is basically going to be the controllers for this. Right now we have move repeating rates and stuff like that. And then we have 3D ball settings. The main thing in here that we want to take a look at is the gravity multiplier. So how much gravity is going to be effect on this ball. So in other words, a gravity of 1 is going to be the type of gravity we experience here on Earth. If we bump it up to 2, it's going to be twice as heavy as it would be on Earth. So a G-force of 2. If you're into aviation and flying, you'll know what G-forces are, or if you ever experienced that feeling in your gut when you're in a roller coaster or going over a hill, you've experienced a G-force modifier. I know this because I used to be a pilot, and I used to be a really good one at one time. So, but anyway, moving on. Now, all of these little ninjas, as I call them, are actually actors in this, and each actor has its own independent characteristics, which is why when I run this, you'll see that no two actors are doing the same thing at the same time. We can control that by clicking on any of the actors, and it will take us to the actor that we want to manipulate. Usually you can tell because you'll see a gizmo that's in it, which you can use to transform or move the actor whatever way you want. So if I click on this actor, it'll go to that one. If I click on this actor, it'll go to the one below it. Now, if we open up the hierarchy on the actors, we're going to see an agent and a ball. Okay, so each actor has an agent, a ninja, and a ball that's on its head. Now, if we click agents, we can see a bunch of different stuff here. Now, the one thing that I really want to concentrate on is the stacked vector. The stacked vector tells the actor how many states that it'll be fed into the neural network. So in other words, is it going to be able to do one thing at a time, 2 things at a time, 3 things at a time, and so on. And we'll get to that in a minute. But those are the ones that I want to concentrate on this lesson. So let's fire it up and let's see what what it does in the state that it's in. And we are holding on. Okay, so here we go, it's running. Let me maximize this so we can see what's going on. So you have these 12 dedicated ninjas who are all trying desperately to keep these balls balanced on their heads and learn and master the art of balance, which I think is a very commendable effort. As you can see, none of these guys are doing the exact same thing. And the reason why is because, like I said, each one of these is independently controlled. So they're all thinking for themselves. And this particular algorithm is taking data from each one of these and trying to apply it to come up with the best case scenario. So let's take a look at some things while we're doing this. Okay. So all of these things are happening in real time. You can see the rotation is going on the X, Y, and Z axis, and that's what's happening. The agents are learning how to balance this on their head. But what would happen if we change something? What would happen if we change the parameters on this? Let's find out. Let's find out by the first thing we're going to do is change the gravity. Let's give the gravity a gravity multiplier of 3. And let's run it and see what happens. Sometimes it won't even run at all because we changed the gravity. We changed a parameter so much that it wouldn't have an effect on certain things, or it would have too much an effect on certain things in some other aspects. Okay, so I'm seeing a bunch of balls falling off of these guys' heads. You see that? So when we affect the gravity, gravity's pulling on these balls much harder than what they're used to. So they're going to be making a lot more errors. But if we keep this running, you'll see a gradual improvement. And maybe, just maybe, they'll get to the point where they're used to it and they'll be able to compensate for all of this. But that's going to take some time. So, as you can see, when we manipulate perimeters on one of these examples, we're going to get different results. Sometimes these results are unexpected, or actually sometimes I'm amazed by some of the results. But anyway, let's go back and take a look. Let's stop this for a minute. Let's put that gravity back to 1 and see if things go back to normal. Or did something happen where now they're trying to learn a whole different style of things? I'm seeing something here. You see this guy? He's having a little bit more of a problem, and so is he. The rest of these guys seem to be doing okay, but obviously we have introduced something and now they have to unlearn it, maybe. Could be. What do you guys think? Notice now that it's getting better. Amazing. Amazing technology I think we have here. So, let's stop this. Let's pick a few of these guys. Let's pick number 1. We'll pick number 1. And we'll set his stack vector to say 12. We'll pick number 3. Do the same thing. We'll mess with this stack vector a little bit. We'll put him to 23. Okay. And we'll go to 5. And we'll do this guy too. So, the stack vector, we're going to really ramp it up here to 33. So let's take a look at which guys we're affecting here. So number 1 is this guy. He's in the middle, off to the right a little bit. Number 3, middle, but he's on the left. And number 5, the guy below him. Okay. Let's see if this will run. Oh, we have an exception here. It was outside the bounds of the array. And I think I know which one that is. Let's take a look at him. Let's bring him down to, say, 6. And let's see. See, sometimes you have to finesse these things because the art of learning is also the art of making mistakes. If we make a mistake, we learn that, okay, we can't go that high, for instance, in this one. Now, so obviously there's another one that is a little too high. Let's take a look. Yeah, let's bring him down to... Let's bring him down to... Let's say 4. And see what that does. Cross your fingers, guys. Let's do this one more time. See, sometimes these things have very unpredictable results. Okay, so we're not getting, well, it moved a little bit, but we're not getting a lot of feedback. Now, why is that? Well, something's happening. Okay, let's take a look here. All right, let's do this. Let's bring all of these stack vectors back down to 1. And I apologize for this, but sometimes happy accidents happen and you can learn from them. Oh, that's why. Okay, so I got a feeling now that this is going to work again. Okay, just as I thought. Here's what we did. We went out of bounds. Well, it's not out of bounds, but we went kind of out of scope. Let's set that guy to 3. Let's set this guy to 2. Oh, we'll set him to 6. And we'll set this guy to, we'll set him to 2. Okay, so let's see if we see any differences here. Very peculiar. Well, that had an unpredicted result. I'm going to be honest with you. So if we put that one to 2, let's see here. Let's see if let's drop this guy down a little bit more. Let's drop him down to, let's say 3. So we have 1 at 1, 1 at 2, 1 at 3. Let's see what's going on here. I want to see if by changing this to a smaller value, if we can get these guys to work longer, is basically what I want to do. No, but I am seeing something that I was hoping I was going to see. So yeah, I'm seeing a little bit of odd stuff here. Okay, so actually this is what I wanted to demonstrate to you. Not everything that you do is going to have a positive result. So obviously with this, when we manipulated these values, it had results that we didn't want to have. Okay. In the first one, we were able to manipulate the gravity, and we saw what that did. So gravity is one of the key forces in here. Stack vectors basically, well, we're basically saying how many things can we do at once? Maybe we were biting off a little more we can chew. Let's try something else here. Let's try number of continuous actions. Let's just do number 1. We're going to do this guy here. Let's set him let's try 6. Let's see what happens. Yeah, very peculiar, huh? Well, that didn't go right. Try one last time. Yeah, it's just not gonna. It's not gonna play nice today, guys. So let's do continuous actions. We're gonna do one. Okay, let's see what we got here with this guy. Okay, let's try that. So we dropped them down. We dropped a couple of them down to one. Yeah, so okay. So these parameters, obviously some of these parameters we're not going to want to play with. Now here's something that I do want to show you, but I'm going to have to, I'm going to reload this scene here. We're going to discard the changes. Actually, we can probably do that. Okay, the other thing I wanted to show you guys here is this. So for these agents, we can set how many max steps that we do. So what this means is how many times is this guy going to go ahead and try this. And what we can do is we can set a limit to it. And by doing that, we kind of stop a phenomena that happens when we go overboard. For example, I was talking to my instructor today about this, and sometimes if you do it too many times, what's going to happen is it's going to actually stop working, because the program's going to realize that the best course of action sometimes is to do nothing, if that makes sense. So let's say that we're training a car to race around a track and not hit the walls, and if we do it too many times, it might say, you know what, I realize that the best way to not hit a wall is just to go forward a little bit and backwards a little bit and avoid the walls altogether. But that's not what we wanted it to do. We wanted it to basically find the best possible path and not just sit there. So that's what this does. So we can do this. So is that 5,000? Let's do 100 and see what happens. Well, let's just humor me here and let's try it out. Okay. So it's going around. Oh boy. Hey, these guys are having a little bit of an issue. So it'll stop after they do about 100 tries. Okay, so he lost his ball. And I guess with this one, the less amount of time you spend, the less they're going to learn. Okay, because in this one, we want them to try to keep the ball centered on their head, right? So the more iterations we go through, the better. That's not always the case with some of these, okay? But for this one, yeah, I think it's better that we put it back to 5,000. And we will. So, what did we learn from this, guys? We learned that ML Agents is a great tool to use for machine learning, because we can actually see visual representations of what's going on now instead of just crunching the numbers, okay? And I think that's neat. We learned that we can manipulate the variables inside of this to do different things depending on what you want to achieve, okay? Sometimes these variables they work, sometimes they have unpredicted results, but that goes along the lines with machine learning, right? It's all about getting the unpredictable results and refining them into something that we can use, at least in my mind. That's one way of looking at it. So anyway, guys, I demonstrated to you that ML Agents is a great tool to use for machine learning, and that these different variables can do different things depending on what you can do, depending on what you want to do with the type of machine learning that you want to do. In this one, we wanted to balance the ball on these ninjas' heads, and we figured out that the more gravity you have, the less of a chance that they're going to have to keep that ball centered. We also figured out that when we're trying to change perimeters and the actions of what they can do, it has unpredictable results. So if we want them to try to multitask in this, it's going to take away from their concentration on the ball, and it's basically not going to work. And we also learned that depending on how many iterations we use is going to dictate how these guys are going to learn. Sometimes less is better, sometimes more is better. In this instance, more is better. Okay, guys? Well, have a wonderful day. That's the end of my presentation, and I hope you like what you learned today. Thank you very much. Have a great day.